to this computer. For those of you who watch the recording, all few of you, you lucky few, we just went over this proposal. It is due on the 1st or the 31st of October. And so now we're just doing a draft read through and fixing up some mistakes. Like there's some minor mistakes with this schedule right here that we need to solve. So yeah, moving on. Then there's the flight sciences team, which is headed up by our dear Evan Barker.
Yeah, that's me.
That is, in fact, you. So responsible for the broad configuration of the aircraft and mostly designing the wing. That's Evan's job. I'm going to help him. Derek's going to help him. But if you want to like tag along and see what we're doing, more than willing to allow that opportunity. But it might get into a little bit of a too many cooks kind of deal. By the way, if you get a chance after this meeting, look up Too Many Cooks on YouTube. Really wholesome fun there. So yeah, then there's the structural design team with the 3 sub-teams. Understands materials and processes, CAD modeling and technology such as additive manufacturing, balsa buildup, and hot wire foam construction. Design and build a sturdy and reliable airframe capable of meeting the mission goals. Again, one word I'd use to describe this club is goal-oriented with a hyphen, so it makes it one word. Propulsion team selects motors and batteries to meet competition requirements set by the flight sciences team. Propulsion team will be doing flight tests, wind tunnel testing, electrical system wiring, and other ground test protocols. Like, making sure we don't blow a fuse or melt an engine. Because that would never happen to us, right?
Ah,
Yeah. Uh, the propulsion team recently conducted a test flight in which they burned out one of our motors, which I'm all well and good for in the name of science as long as it doesn't happen too often. Because those motors are expensive. Like I think the one that got burned out was $90, 110, something like that.
Yeah, I'm pretty sure it's like that. Yeah.
Yeah, so they aren't cheap, so we don't try and melt too many of them for fun. So yeah, we have our Gantt chart to set deadlines, and each critical system has a date. I might need to edit that because we don't have actual the dates on here, but yeah, that's easy enough. Water under the bridge. And then speaking of burning out motors, then we have the budget for this year. Most of this is already paid for by ASU and maybe some sponsorships. Still waiting on some information regarding that. For those of you who want a closer look into how much money it takes to build a competition airplane and go to competition, it's about $2,500 approximately to buy all the parts to make the airplanes that we do, not including a bunch of consumables and other stuff, and another bunch of money to actually go to competition, pay for rooms, that kind of thing. So yeah, it is not cheap, and we are thankful for ASU to allowing us to do this sort of thing. Couldn't do without their support. So we have our competition budget here, divided into the sections, as well as concerns about COVID-19. Then we have the conceptual design approach right here. This year, the primary goal of the competition is to design an aircraft to tow a sensor that will be able to be remotely deployed and retracted from inside the aircraft. The aircraft must have a maximum wingspan of 5 feet, have a maximum takeoff distance of 100 feet, and have a final weight of less than 55 pounds. The sensor must have a minimum length to diameter ratio of 4 and feature a minimum of 3 external lights that are visible during the day and flash in a pattern. Sensor must also have a container that it will go inside to ensure its survival from a short drop. The first mission is known as the staging flight, which involves the aircraft taking off, completing 3 laps of the course in under 5 minutes, and landing without significant damage. Scoring is pass-fail, 1 point for completion. The second mission is titled Delivery Flight, and it is a payload-centric mission. The aircraft must have a minimum of payload of the functional sensor inside its shipping container, as well as the deployment and recovery mechanism. The aircraft must carry multiple shipping. Aircraft can carry multiple shipping containers to improve its score. That is something I need to change.
There's another thing. The sensor word right after 55 pounds, it had an uppercase S, but following that 9,
Ah,
it had a lowercase s.
yeah, that's something I also need you guys to look out for. Is whenever I say mission, I have it stylized as being capitalized, and there
Okay,
are
okay,
some areas where I have it not capitalized.
okay,
I can control F that later, but if you
okay.
see something like that, call it out. Uh, yeah, so complete 3 laps. Points are awarded based on the number of payloads carried and the time to take off and complete 3 laps. Landing is not included in the mission time. The third mission is the sensor flight. The aircraft must take off, deploy its sensor before the first 360-degree turn, and complete as many laps as possible over the course of 10 minutes, with the sensor deployed. Landing is not included in the 10 minutes. The aircraft is scored based on the length and the weight of the sensor, as well as the number of laps completed in the 10 minutes of flight time. So, yeah, the ground mission requires that the sensor demonstrate its survival after being dropped on all 6 sides from a height of 10 missions. That should be 10 inches. This one. After the drop test, the team is timed as it loads the aircraft for mission 2, unloads the aircraft, and then loads for mission 3. Then we have the sensitivity study portion of the conceptual design approach of the aircraft. The scoring of this year's competition relies on 2 competing factors: sensor size and sensor quantity. Mission 2 is driven by how many payloads the aircraft can carry, while Mission 3 is driven by how large of a single payload can the aircraft successfully deploy. If the aircraft can successfully complete both missions, the aircraft's performance is only responsible for 1 point in each mission. The payload itself is scored in Mission 3, based off of the payload's length and weight. The payload's weight is ultimately constrained by the available volume to fill with mass by the minimum length over diameter requirement of the sensor. Senior. A longer sensor can have more mass inside and more volume to fit the required electronics. Therefore, the length increases the score both in length and mass. However, there is the additional constraint of the deployment. The rules require that the sensor must be stably deployed a minimum of 10 times the length of the sensor away from the aircraft. This puts a limit on how long the sensor can be, as simply dropping the sensor from a bay will disqualify the aircraft. To contrast with Mission 3, Mission 2 is driven by the number of payloads completed. Ah, that is something to change.
So is the L over D length over diameter or lift over drag?
Length over diameter.
Okay.
I should probably define
Yeah, because
length of
that's lift
diameter.
over drag, kind of seems like it.
Yeah. 4, feature minimum of 3 external lights. If the aircraft complete payload's weight is ultimately constrained, the minimum L over D increases. There's additional constraint of the deployment, stably deployed 10 times the length of sensor. This was simply dropping sensor from a bay aircraft. Where was the other thing that I pointed out was a mistake in this? Payload itself is scored mission 3 based off the payload's length and weight. That one. Don't want any seniors in this paper. Contrast to mission 3, mission 2 is driven by the number of payloads completed, so smaller payloads are incentivized. Smaller payloads weigh less and have a lower drag penalty, whether in driving the fuselage dimensions or with external carriage. While mission 3 is limited by the sensor deployment, mission 3 is limited by takeoff requirement. That should be mission 2. Gosh, it's almost like as if I didn't proofread this. Is limited by the takeoff condition. As the wingspan of the aircraft is limited to 5 feet, the aircraft must weigh less than 20 pounds to have a low enough wing loading to take off, meaning that to achieve a good mission 2 score, the aircraft must utilize the full length of the wingspan limit. So 2 things there. Capitalize mission, full
You missed
length of the
and
wingspan.
upper.
Which one?
Like when you're talking about the 6 sides where it needs to be dropped.
Yeah.
Go there.
Oh, I changed it in here, so. Oh, ground mission, you mean? Yeah, I'll just do that one. So with these design parameters in mind, Airdevil's put together a multidisciplinary optimization code to study the interactions between the 2 main parameters, sensor quantity and sensor length. The MDO starts by estimating the fuselage dimensions based on the quantity and length of the sensors. Those dimensions feed weight and zero lift drag estimations. Then takeoff distance and level flight performance are estimated using the weight, drag, and propulsion data characteristics through flight testing. With the flight characteristics determined, aircraft performance is estimated with the separate missions broken up into takeoff, straights, and turns to calculate lap times. Finally, the aircraft is scored based on the mission rubric, checking to see if the aircraft's configuration can take off within the allotted 100 feet. The MDO then iterates through the varying combinations of sensor length and quantity to determine the available design space and the resulting scores. See figure 4. That is this figure. The end result of this effort was that the score frontier was shallow. Whether the aircraft had many small sensors or few large ones, the score is more dependent on Airdevil's ability to finish the missions and achieve a high report score. As such, a design optimizing for reliability would lead to the greatest chances of success. Greatest chance of success. That should be will, because it is present tense. From the sensitivity study performed, we saw that the combination of rubric, weight, and our building capacities suggest Airdevil's designed the aircraft to be capable of carrying 6 sensors at 11 inches long. These sensors will be carried in a configuration of having 2 external and 4 internal. Our aerodynamic performance team deemed that the best aircraft configuration for this arrangement that will maximize our scoring leads to design that will have a 5-foot span and an aspect ratio 3 wing, with a motor on each. That should be a 2-motor setup. This design ensures that our aircraft scores well enough in both missions to be competitive, as mission 3 is limited by the deployment of the sensor and our ability to ensure functionality of the sensor, whereas mission 2 is limited by our ability to fit the electronics in the small sensor.
Hey, Dan. Where it says aerodynamic performance team, should that be FST?
Yeah. That is our FST. Deemed that with a motor on each wing. That way we don't have wing repeated too often. This design ensures that our aircraft scores, blah, 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 is limited by our ability of the deployment of the sensor. Deployment sensor, whereas mission 2 to fit the electronics in a small sensor. The aircraft uses a high wing setup to allow for an easily configurable payload bay, integration of external stores, and minimal interference with our sensor deployment in mission 2. Ah, that should be mission 3 and capitalized. It's a double whammy. Our release mechanism for mission 3 will open the lower side of the aircraft with bomb bay style doors. This allows us to run a connection point of the sensor to as close to the center of gravity as possible, as to not induce excessive pitching moment on the aircraft, as well as to not induce excessive pitching moments on the aircraft. On the aircraft, harming its stability. As per the rules, the two connection lines for the sensor will need to be 110 inches plus the extra leading to the connection point within the fuselage. This distance of the mass from the aircraft will be considered in the final performance specifications and in the maximum G loading used for aerodynamic design. Looking at figure 5, the reader can see that we require a rather square fuselage to contain all the controls, electronics, batteries, and sensor containers. Placement of all the components will require the aircraft to balance with the same CG in every mission. This design carefully considers the location of each component so that they can be moved to not affect the center of gravity location. To this end, the battery position will be able to change for each mission relative to cargo stores. Decision.
I don't think the reader can see that we require a square fuselage from that picture.
Yeah.
It's
Yeah, I think that should be rewritten to say like, as the fuselage needs to contain all of these parts and be fairly modular, we chose a square fuselage, as can be seen in figure 5.
yeah, that makes more sense.
Somebody write that down and I'll put that into the paper later. The decision to use a 2-minute setup was driven by the takeoff and speed requirements of the aircraft. A high static thrust allows for the mission 2 takeoff requirement. Design is intended to use about 60% of the allotted 100-foot takeoff during our heaviest mission, leaving comfortable margins for adverse conditions at the competition, such as heat and crosswinds in Tucson. Having 2 motors also allows us for less sensitivity to the thrust laps of RC aircraft propellers, which is the dominating term in the speed performance of the aircraft's lap time. See figure 6. So yeah, that is the thrust laps data that we obtained from Max and Evan's test flights earlier. So Airdevils uses Vorlax, a public domain Vortex Ladder CSD program to test different layouts and aircraft configurations. Our FST uses the software to trade aerodynamic configuration, select appropriate CG location, and select tail size to ensure stability and control. Pretty easy. Last stretch, manufacturing plan. Manufacturing element of the competition will be the focus of the SDT. Each sub-team designs prototypes and ground tests the respective subsystem before its integration into the production aircraft. The FST will be responsible for the construction and testing of all air services, as well as to ensuring that containers can accommodate all required subsystems. That should be the SDT's responsibility. With regards to propulsion team.
I know we had a additional team. It was like a mass
Yeah, mass
something
proper
team.
use. I didn't see any of that mentioned in here.
Yeah, because I removed it from the
Yeah.
thing because I couldn't think of anything that it would do.
Yeah. Is Christian here? Good. I can I should talk him a little bit. But like the mass properties is supposed to be responsible for making sure that everything is weighed correctly for the controls portion of it, making sure that we have enough roll rate, yaw rate, and stability. But it's really difficult to do that and build the plane at the same time because it's a self-feeding problem. So we pray that doesn't happen.
All right.
That's yeah. They aren't mentioned here, so not having them in either is not a big loss. Manufacturing plan. Payload boy will have to complain. Where does it talk about? That one. Responsible for the Yep, that should be good enough. The payload bay will contain the complex doors and winch mechanism to accomplish the retrieval. To ensure that the fuselage has the strength to retain all these components and the flexibility for complex geometry, the fuselage will be made of a composite layup on a 3D printed mold. This technique is new to Air Devils, but has been successfully integrated by other groups such that the technical risk should be low. Yeah, that should be good enough. Fuselage also integrates a carbon fiber keel for strength and the integration of the tail structure and wing. The nose of the fuselage will be made of thin wall 3D printed material. This will ensure that the nose properly shapes the flow over the fuselage. The wing will be a balsa buildup using balsa torque box spar covered with plastic film. This manufacturing method can easily incorporate a complex organic airfoil design, and Air Devils has a suite of internal tools to design and manufacture the wing. This type of design makes significant use of laser cut wooden parts, ensuring manufacturability and precision. The wing also makes use of 3D printed parts to mount the motor and the wing to the keel. The empennage will be made of either hot wire cut extruded polystyrene foam or with balsa forms on carbon fiber spars. Both techniques have been well practiced by Air Devils, so low technical risk is expected. And then the testing plan.
The that last sentence will the also uses 3D printed parts to mount the motor to the wing and keel. Kind of sounds like we're mounting the motors to the wing and also to the keel instead of mounting the motors to the wing and the wing to the keel. But I don't know if that's just
Okay, I can also makes use of 3D printed parts to mount the motors to the wing and the wing to the keel.
yeah.
Starting to sound like rap lyrics. 3 to the 1 to the 1 to the 3. I'm not going to say the rest because I'm being recorded.
Yes, we all know the song.
Mount the motors to the wing and the wing to the keel. All right. Testing plan, 3 categories corresponding to a specific subteam. The FST will be responsible for ensuring the correct geometry and balance of the aircraft based on the conceptual design. The SDT will be ensure that the aircraft is capable with standing flight loads with a 1.5 factor of safety, as well as test mission payload systems. The PDT will ensure that the motors and batteries are properly chosen to meet takeoff, cruise, and endurance needs of the aircraft. The FST is in the process of developing the initial airframe geometry. They first carry out an unpowered glider test to ensure the aircraft layout and CG location have been designed properly. This team will then outfit a powered prototype of this layout to prove basic airworthiness and demonstrate stall characteristics. After that, dummy towed payloads will be flown with the prototype to test the uncommon flight dynamics of that configuration. The STT will use a spiral design and test approach to develop optimal airframe and mission systems. See figure 7. That's figure 7. Each component of the airframe will be tested individually before integration into any aircraft iteration, ensuring it meets performance requirements. All aerodynamic surfaces will be loaded with the sandbags to 3Gs to check that no structural damage occurs while in flight. Sensor electronics and operations will be tested rigorously on the ground and in the air to ensure reliable performance. Sensor recovery systems will also be tested on the ground and in the air to check reliability. PDT is currently in the process of systematically testing motors, props, and batteries to find the best combination for the needs of this aircraft. Air Devils is currently using a separate aircraft to capture thrust, airspeed, and acceleration, angle of attack, and battery power. This test aircraft is crucial in gathering accurate propulsion and flight data to verify performance of each part of the propulsion system. PDT is now working to determine thrust lapse data for each configuration, so the final aircraft can meet the 100-foot takeoff requirement, maximize speed, and maximize endurance. And that's it. One thing we could add, if we had space, or if we cut down in some other areas, is another picture showing the flight aircraft, the test aircraft that we have. I could probably get rid of this thrust lapse information in order to include that.
One thing is on the Air Devils is currently using a separate plane to capture thrust, airspeed, acceleration, angle of attack, and battery power data. It's probably add the
Yeah.
word data there.
A little wordy. Agreed. Yeah. Separate aircraft to capture. Also, the angle of attack isn't that important for what we're doing. So,
Yeah, let's scrap that word and put and battery power data.
yep, that works.
All right. We have 2 parts earlier that we pretty much put off.
Yeah, which the first was
The Gantt chart, my paragraph. Well, actually, I upload the corrected Gantt chart.
gotcha.
It's called Gantt chart fix.
You guys are seeing inside the inner circle. That's why. Wrong one. Gantt.
The changes is pretty much changing those stars to a triangle. This matches color, so it is not a milestone looking thing, but as a more of a regular scheduled date. I'm not really sure how well this Gantt chart works.
You could also put in a like a legend, basically, like saying, you know, the star is our AIAA set deadlines, and the squares, diamonds, our set deadlines. Something maybe explaining why we have the 2 different shapes.
Yeah, that's something I'll have to make in Paint or something because this does not have legends.
Gotcha.
Or if it does, I don't know.
Yeah.
But content-wise, is it good?
Yeah.
Okay.
That's basically what we had in previous years, and I've never seen any complaints about our Gantt charts. So
Yeah, I will get that key and put that on there. Then when it comes to management summary, the paragraph after propulsion team.
management summary.
It's like in the middle of that page.
Propulsion team tests and selects.
And not that one, the one below it.
To ensure the production aircraft is complete this time.
Yeah.
Uses the Gantt chart to set deadlines for completion.
Yeah, it's badly worded. Plus, we don't really have subtasks. So. And it's kind of unrelated fluff, I feel.
Okay. Do you think we can cut it?
Well, no, parts of it. Probably the every critical subsystem is also given a date necessary for incorporation. I think that is kind of fluff.
Yeah, we don't actually even cover that. So
Yeah.
set deadlines.
Whoever wrote that's shit. Oh wait.
Don't be so hard on yourself.
I don't know. To be fair, I only wrote it in like the afternoon, so.
Yeah, uses a Gantt chart to set deadlines. Deadlines and track major milestones. That works. And then mark the diamonds as major milestones.
Okay, major milestones, and then the stars as due dates.
Yeah. Or deadlines. So yeah, while he's doing that, anyone have any questions regarding the proposal?
Oh, the one more thing is the going down to the square fuselage thing.
Yes.
I don't know if we actually need that this early because isn't the fuselage shape sign we determined during the detailed design?
This is supposed to be kind of like our initial configuration, which is
Okay.
highly dependent on payload. So I will.
Yeah, it just needs to be reworded anyways.
Yeah, I will write that out in a separate thing. Where to contain the. Maximize usable internal volume and use different missions to ensure proper CG location for stability. What happened here? There we go. All right. So yeah, anyone have any questions regarding our proposal or anything that you think would be improved? If you want, here are some of the top proposals from 2 years ago. This is U of A's. They had a flying flapjack for this year's or for the 2019 competition that was very unstable, to say the least.
This was one of the better proposals.
This was the number 2 top scoring proposal.
And they had that as a plane. What
They
the
had the
heck?
flying flapjack
Oh my gosh!
because
It's not
From good to bad in one year.
yeah, it's because they had a design. Their MDO setup told them that they should optimize for wing loading to complete the mission for some reason. In order to ensure like a short takeoff, they wanted minimum wing loading. And so this design gives you like the most wingspan within a certain, or like the most wing area. So it optimizes your wing.
It's a box.
Yeah, it makes sure you have the most of the box filled as possible. But really, like most of this wing area is basically useless anyways. So that's
Wouldn't a biplane be more helpful then?
so a biplane would be, but that would require you to have 2 folding wing mechanisms.
Oh yes, no, I forgot about that.
Let's have a biplane this year then.
Yeah, that's not really what the scores show. Plus, well, I guess a biplane wouldn't be a terrible idea, besides the drag. So,
I think our battery limit is the biggest factor still.
yeah, that's something we don't actually iterate in our design. This team actually didn't even go to competition, so had a neat folding.
Oh, we need to get
mechanism.
cool headers like they have. That little.
I think there exists. They exist somewhere, but
Do we need more pretty pictures of our airplane?
Yeah, it looks like a lot of those people have a lot more graphs and junk.
yeah, they have a lot more. Well, U of A has like 3, 4.
Yeah, but then they have like bullet points. And look at that.
Oh yeah, this is just they're breaking out the mission requirements, which isn't a terrible idea to do this, but
I feel like that takes up more space.
yeah, they have a lot of wasted space here.
How many teams actually submit a report or a proposal? Do we know? Like 110 teams get in, but like do only 110 teams actually submit anything? Or is there more than 110 teams that submit?
Wow, you can't even see the 2019 rules. It's funny. So 110. There's 110 teams selected, right? Sorry, but only 61 teams actually went to competition. Or like, so there's a maximum of 110 that they select. There's 104 teams that actually submitted reports. And of those, only like 60 went to competition. And here you see Stanford University, who was ranked formerly number 2 in innovation. Here they are ranked 61 out of many because they got a really, I think that's honestly one of the lowest ground mission scores. Some teams didn't even complete ground mission. But yeah, they got one of the lowest ground mission scores. With
How do you not complete the
result.
ground mission? What the?
I don't know.
They can't drop their bombs or something, I guess.
Maybe they took like 10 minutes to like put everything on.
Jeez.
step on their plane while they're loading it.
Yeah.
Where are we at again? Number 17? No.
Yep.
Yeah.
17. Whereas we were, not the fastest, but better than
Dang.
Stanford.
A 0.3
I think I
for
have video
ground.
of you doing that doing that loading.
The second one I thought was really fast, but I guess not.
Yeah. It was faster than we had originally. That's what matters.
Yeah.
Like the other thing about this year was that if you look at these if you look at the top proposals, one thing that they exploit in the results is that mission 3 had no limit on the score.
Mm.
You look at USC, right? They're like, oh yeah, this is basically showing that you get infinitely many score by optimizing for mission 3, whereas this year it's basically that mission 2 and mission 3 are both worth the same in terms of aircraft
Oh yeah,
performance. They're
because you
both,
get an extra point or whatever for every bomb dropped,
yeah,
and here you have you can't get any extra points at all.
right. So it's 2 plus this ratio, where this ratio is our own aircraft's performance. And in mission 2, it is 1 plus our aircraft performance. So as long as we're able to complete both, our performance matters
Mm.
equally between the missions.
Yeah.
Hence why we have so many charts open. Hence why we have like a fairly shallow thing here representing scores. And by the way, while it was said in the report that we're doing like 11 and 6 or something, I think it was 11 and 6. We'll probably end up doing like 8 10-inch sensors or something like that.
Yeah, 8 would pack well.
Yeah. Basically because
So for the ground mission, you have to load all your sensors in, right?
Yeah.
Okay. Because like a ground mission for the 2 years ago, you only had to do 4 bombs, even if you had 20 bombs.
Mm-hmm.
So this one is kind of like, it's just a little different.
Yeah, that's one limitation of my design optimization is that I don't take into account a ground mission score.
But I guess the ground mission will also count the same, right? You have a factor of 1.
With the ground mission, if you have one very large payload,
mm-hmm.
like you stick that thing in there and you're done.
Yeah, that's what I'm thinking.
Whereas we'll have to cram a whole bunch of sensors into our actual aircraft. So
somewhat it almost seems like it's more beneficial. I don't know.
But
Wait,
the other factor here is that the limitation on sensor deployment is very fuzzy.
Yeah, that's gonna be interesting to see. I always forget about that part.
So
it's really hard to have a big sensor.
Yeah. So having a more conservative approach by optimizing, basically, if I were to go in here and disincentivize sensor length, and instead of doing this, do like preference shading, right?
Mm-hmm.
I need to set the other objective as overall score, right? Having a long sensor isn't good, while having, a short sensor is better.
Yeah.
Short kings.
For that, do we know what we're gonna do for the drop mechanism yet? The roller upper.
Yeah.
The winch.
It's gonna be a winch.
Yeah, but are we gonna do that as a second person, nice and simple, or do you want to try to do the Arduino thing with it?
Second person and the Arduino thing, I think.
Okay, because
Just-
we're looking at the stuff to buy, and I think we're gonna have to buy the Arduino little boards, right?
yeah, Arduino Nano. Those are like $20. They're not expensive.
Well, I mean, we just need to put it on the list is the main thing.
Yeah.
Actually,
Actually,
real quick, Daniel, when's the deadline for ordering things?
Ordering things, we can order them.
no deadline.
Yeah, there's
Okay. So like we could hold off on the electronics for now, right? Because I'm planning on experimenting with some smaller boards to kind of
yeah.
Okay.
reduce the
Yeah,
The only
size
thing-
factor.
as
The
long
only
as we're
thing-
doing stuff with them, that's all that really matters to
Sure.
me.
Yeah. The only thing is that we've already ordered a couple LEDs. We're like
Yep.
$75 worth of LEDs. So
Yeah, I think that's fine.
we have
That's
those in the pipeline, but that's the only thing we have right now. We're gonna order some foam soon.
Yeah, foam, and through Fury, since I really haven't used my budget this semester, I threw in a few nanos that we can just
Oh,
keep
nice.
for the
Okay,
club.
okay.
Yeah.
Um,
Do you know what density of foam we should buy?
No, I've been guessing 1 pound.
yeah, I looked at that link and it doesn't have, or I don't know if we just didn't fill it out, but we don't know. From that link, it doesn't save your options or whatever.
Yeah.
No.
So that might be why it was.
Do you want the pink stuff?
I think this foam is going to be better. It's more rigid. I think we can get the pink foam. What was it? Poly. Was it
Styrene, I think. I thought.
Styrene foam.
Polystyrene foam's the one you're on, I think.
Yeah, this is polystyrene. This is EPS. I think. What did I say is the other stuff that they use?
XPS?
Yeah, XPS, which
They don't
is
sell XPS here, I don't think. Oh, I didn't see it.
yeah, it's more difficult to find. So
I read
I
it's
thought there was a local
better,
supplier.
but
I thought there was a local supplier by like the airport or something.
yeah, there is, but we have to. That's what this is what Saki sent us. So this is what we.
Oh,
Need.
okay. Yeah, then that whatever. Yeah, I don't know what density to get.
Well, here's the potential uses, right? Cake interiors or hot top covers. Which one are we going for? Hot top cover or cake interior?
Probably right in the middle.
Okay.
that
Well-
doesn't really work.
I don't know. I guess we probably got a 1 pound density. I don't know. But if
The
we're only doing it for
difference-
prototyping, there's no reason to get the lighter one, I guess, because if it's too light where it's not actually sturdy enough, then that's going to be really bad.
Mm-hmm.
The price difference is only like $6 for a single sheet between 1 and 2 pounds, so it's not big.
Yeah, I would think maybe just a 2 pounder.
Yeah.
We can do
I don't
this.
want to. I just don't want it, the 1 pound to be so flimsy that like the trailing edge is like floppy.
This is what 24 by 48. So
I think
Yeah,
are you
so-
on?
it's a pretty good.
Oh, you're in the 4-pack, aren't you?
Yeah.
You want a 4-pack, or do you want?
Evan, how much space do you have in your garage?
I have space as
Um,
well.
Yeah.
Yeah, I don't really think I have too much space for these, but if someone else does, then
Yeah, if you want a bunch of foam, I can hold it. I got plenty of space.
okay. It's not like crazy big either. It's 2 feet by 4 feet, I guess. It's not like
But it's 4 of them, unless I'm reading that wrong.
It'll
Oh.
stack up like a
yeah.
Yeah.
The one I'm
like
looking,
5
the
inches
one
deep.
the one that's in the link only has single packs, so I don't know
Yeah,
if you've
that's
clicked on
single
another link.
Yeah. You can find. They come in single and 4-packs.
So whatever amount, just let me know, and whatever thickness. I also am not really sure about that. As far as wings go, I'm not sure how thick or close they're gonna be.
I thought what is it, like 3 inches is probably like good.
I think 4, because we have a T over C of. I just put 12% in there, right? So we have
Mhm.
12% thickness at the thickest point, 12% of the cord, and our cord is
18 or 16.
let me see, our cord is like 1.7 feet, so
Jeez.
20 inches is that's also like, turns out aspect ratio doesn't really change the score that much, so we can improve this somewhat and it doesn't really affect the score.
But 12% on 20 inches is only like what, 2.2 and a quarter inches or something?
Last year, I
2.5
remember some.
inches.
I remember some much fatter airfoils at the
Yeah,
root.
we had some fairly thick airfoils.
Yeah,
So
4 would be good then. Yeah.
I
Sure.
think 4, so that would give us
Or,
like
okay.
what, 0.2, 20% thick. That's really thick.
Well, it's always good to have a little extra the cutoff than like getting right to the edge every time, I think, too.
Yeah,
Like gluing it all together, the
yeah. And if we
thingies.
reduce, like if we have a better aspect ratio, it means that we can have more room to spare. So yeah, probably 4 or 5 inches. What's oh, that's something that we can do is we can actually, we have some fairly like rectangular chunks of foam, right? Like,
Yeah.
can you like weigh one and get the like a rough estimate of its
Oh,
volume?
I suppose I could, yeah.
Like a fairly square chunk and just weigh it and just be like, hey, you know, it's
Yeah.
X many inches. It's
That density, is that like cubic
pounds per square
density?
foot.
Oh,
Or
square
pounds
foot,
per
okay.
cube foot.
Cubic foot. Oh, that's what
Yeah.
I thought, yeah.
Yeah.
Cubic foot. But I don't know. I feel like 1 pound of cubic foot is pretty good for us. Yeah, I'll go weigh it. I have no idea.
Yeah.
Why
'Cause,
can't
like-
we buy the same one?
What? Oh, we don't know which
What?
one we have. So that's
Oh.
that's like the
Where do
that's
we
the-
get it?
the internet.
The
We've
problem
apparently
is
ordered
every
from
year
them
we don't
before.
keep track of the same stuff.
Yeah.
And every year they change who we can buy from.
Yeah.
That too.
Yeah. So I have,
Um,
that's why I have like the order tracking thing behind the scenes to try and improve that aspect.
Max,
Yeah.
you have this stuff on here for the Hobby King order, or
hmm
are we able to actually order from Hobby King though?
Oh, I don't know. Has that been a problem before?
I think so. They're like one of the Chinese sites.
Really?
Is there a way to look up if they're?
Hey, look, they got an American flag up there. That's all I need.
Yeah. That does it for me.
I just thought in the years past we couldn't do it. So
I'm not
the
sure.
other thing with those motors, they're like 2 times bigger than the motors we were using last year, just like in weight.
Oh,
So, I mean, they would work. We would just not be using them to the max potential. Because like
Okay.
our motors last year, like we're like max wattage of like 700, and these are like 1300.
Mm-hmm.
So like, and with our batteries, we're only able to, for at least for the long duration, we're only able to use like, I don't know, what was it, 400 and 500 watts for the 10-minute mission. So
We have 177.6 watt hours total.
yeah, what was the one thing I put in the Slack? I kind of did that really rough measurement.
Is that in the propulsion section?
Yeah. Yeah, so we were able to use 800 or 420 watts per motor. So on the long duration flight. So I mean that would help for like the takeoff, like burst thrust,
Mm-hmm.
or like the mission 2 going really fast. But
I was just trying to find some 500 kVs.
yeah.
I guess those tend to run pretty high on wattage as far as I've seen.
Yeah. The other thing is to kind of get, I guess, maybe a good motor size. I think the motors we were using last year when I looked it up, they're like 130 grams a piece.
Yeah.
So
Sounds
that
about right.
like just the general weight kind of gives you like a kind of general idea of how powerful it is.
Yeah.
But again, there's really not like there's not always that many types of motors with like low kV, so this really might be the only option.
Right.
But I mean, it would also be just fun to test too because they're kind of cheap. So
Yeah. I know.
so I mean, I think the biggest thing is if we're able to order it from Hobby King, that'd be sick. But
cool.
Yeah, maybe send Max. Maybe send an email to Melissa or who's the ordering guy again? Did you ever figure out his name?
Yeah, it's on the emails.
Was it the
Australian.
Riley or Ryder or something? Oh, the guy that I went and picked up stuff from? Is that
we
Raymond?
get sponsorships from them.
Raymond Keller.
I actually got emailed from drone group. You guys see my message in random about that?
Oh yeah.
Let me see if I can. You guys can see my email. Oh no. It was.
Oh, maybe we can go through Hobby King. I don't know.
Yeah. NXP Hover Games. They asked me if.
Oh, my Drone Devil club over in Poly was looking at that, and it turned out that like with the COVID thing, it's like only programming. So
yeah, that's kind of what it looks like.
Yeah, it's meant to be autonomous stuff. So
yeah, I told them like, hey, yeah, we do drones, but kind of the fixed wing kind, not the whirly spinny kind.
the whirly woos. Yeah.
Yeah, no whirly woos here. So, all right, that's basically. I'm gonna stop the meeting there because we kind of just been ranting for a little bit.
I almost have that keyed up, but I'm just currently pasting on my drawn key onto the picture of the Gantt chart.
Oh yeah, Max, you have those other Motorfly motors, right?
Oh, stop recording.